So we're going to look at another example on finding the area of a triangle. So let us look at this particular example where we have the measure of angle C, we have the lengths A and C. So guys, in order to find the area of this triangle, the first step is going to be to actually draw this triangle, and from there we can start finding the area or evaluating the area of this triangle. So let us draw that triangle. Uh, I'm going to draw it like this. Guys, you can draw it the way you like. And let us call this as A, and let me call this as B and this as C, and this is my angle A, which is not known. Angle C is known to me, so angle C is 32 degrees, and guys, then I have my length A, which is 16 feet, and I also have the length C, which is right here, which is 10 feet, and then angle B is missing here as well. So this is my triangle based on this given information, and from here, now looking at the triangle, we got to figure out how to find the area of this given triangle. Now guys, we know the formula for the area of a triangle. There are three ways of expressing the area of a triangle using the sine function, and in all the three ways, the key is that it is one half of the product of the any two sides, but times the sine of the included angle. So in this case, all the three sides are not known, only two sides are known. In this case, it's A and the C, but the included angle is not known to us. So we know if we have to write the formula for the area of this triangle, based on what is given to us, especially the two sides, it's going to be one half of A times C, which is the product of the lengths of the two sides, but then it has to be multiplied by the sine of the included angle, and sine of the included angle will be sine of B. But guys, B is missing. Although we know A and we know C, but B is missing, so that means we cannot find the area of this triangle, and we cannot use angle C in this formula, because that is not the included angle between A and C, right? So what does that mean? Does that mean that we cannot find the area of this triangle? Well, just by looking at the given information, we may say that we cannot find the area, but guys, we already know some other concepts and some other things that can help us maybe to find the value or measure of this angle B. So if we are able to find the measure of angle B, then we should be able to write or find the area of this triangle. So in order to find the measure of angle B, guys, we have already learned the sine law. Let us start writing the sine law and see if that can help us to find the measure of angle B. So writing the sine law for this is pretty simple. Let us use the A over sine A. We know A over sine A is going to be equal to B over sine B, B over sine B, and that is going to be equal to C over sine C. That is the sine law, one of the ways of writing the sine law. So let us now substitute the values that are already provided, and then we can see what are the missing pieces and if we can actually figure those out. So I have the length A, which is 16 over sine of A. I don't have the value for A, so I'm going to just write sine of A equals to B. Do I have the value for B? No, so I'm just going to write B over sine B. We don't have the value for the angle B as well. Then guys, do I have the value for C? Yes, it is 10 over sine of C. I also have the value for angle C, so it is sine of 32 degrees. So looking at these three ratios, guys, we can clearly see that if we take up the first one and the third one and we set them equal to each other, because they are supposed to be equal to each other, then from there we should be able to figure out the value for angle A. So let us go ahead and set those up. Guys, keep in mind we cannot use this ratio right now because both the pieces are missing. Both the length as well as the angle is missing. So that is not going to help us to solve for any one of them. So we have to use the first one and the third one. So I'm going to take up the first one and the third one. 16 over sine A equals to 10 over sine of 32 degrees. Guys, from here we're going to cross multiply. And then from here we will get 10 times sine of A equals to 16 times sine of 32, just by cross multiplying. And to find sine A or find A by itself, first I have to divide both sides by 10. 10 will cross out, and now from here we have to use a graphing calculator to figure out the value on the right hand side, and then from there we can find the value for A. So I'm going to use my calculator to find that value. So I have to do 16 times sine of 32. Make sure your calculator is in the degree mode. Divide by 10. So guys, let me go up to 4 places. So I get 0.8 479. Let me round it to 4 places. Now guys, from here, let us see what we can do to figure out the value for A. Well, I think we have space here to write that. So we got, from here guys, what do we get? We got sine of A equals to 0.8479. And we know that sine can have any value between -1 and +1. And at the same time, we know that sine is positive not only in the first quadrant, but it is also positive in the second quadrant. So the first angle that we have to find is, we got to find it using the graphing calculator or using any calculator which has an inverse key. And then the other angle we can find in the second quadrant by taking away 180, by doing the math, 180 minus the angle that we found in the using the calculator here. So guys, to find that angle A, we have to use the inverse key on the calculator. So second sine inverse, and then I have to type in 0.8479, and what I get is what I get for A is, the first one I get is the measure for the angle A, which is in the first quadrant, is let me round it, so it is going to be 58 degrees. So that is what I get for when I solve this equation for A. You have to use a calculator for that, the sine inverse key on a calculator, and this is what I use on a calculator, sine inverse, and I typed in 0.8479 to find that angle A. But this is not the only angle. The other angle can be found by taking 180 minus 58, because sine is positive in the first as well as in the second quadrant. So it's 180 minus 58, and that is 122 degrees. So we have two values for A in this case. So guys, what does that mean? That means we are not only going to have one triangle, but we're going to have two triangles. So if we have two triangles, that automatically means we'll have to find the area for the first one as well as for the second one. So we'll have two answers for the area of this triangle. Okay. So, but guys, we would not have been able to figure this out just by looking at the triangle or even looking at this information. So one has to do all that math to figure out, like now that we can see that we're going to have two triangles. So once we have two triangles, let us do it. Let us break it into two cases, and then from there we can figure out the area of both the triangles. Okay. So the first step is, guys, let me get rid of this information. I'm going to preserve my angles because I need those. So maybe I'll write them somewhere else so I get my first case, case 1, A is 58 degrees, and my second one, this is my first one, and second one, measure of angle A was 122 degrees. Okay, so for the case 1, I have measure of angle A is 58 degrees, and then I have measure of angle C, which is 32 degrees. Now from there I can find the measure of angle B, because we know the sum of these three angles is 180 degrees, so it's going to be 180 minus the sum of the other two, 58 plus 32, so it is 180 minus 10, 90, so it is 90 degrees. So measure of angle B is 90, so it does not exactly look like how we actually did draw it, but so basically that's fine, guys. We don't know how the figure is going to, how the triangle is going to be just by looking at this information. Once we explore, then we figure out how the triangle looks like, but that's not so important in this case. What is more important is we want to figure out the area of the triangle. So once I have my measure for angle B, we should be able to find the area of this triangle, which has these angle measures, and we don't need to find the third side, because we don't need the third side to find the area of the triangle. And this problem is not asking us to solve for the sides or solve for the angles. Yes, we had to find out this angle because we needed that to find the area. So it's going to be 1/2 of A times C. A is 16 times C is 10 times the sine of 90. Guys, this can easily be simplified. It's 1/2 times 16 times 10, and sine of 90 is 1. So when we simplify this, it's going to be 160 over 2. So it is 80 feet square. That is going to be the area of one of the triangles. And then to find the area of the other triangle, let us go ahead and find the area of the other triangle. Maybe we can figure this out right here. Guys, the area of to find the area of the other triangle, the first thing we have to do is, again, we have to see what is the measure of angle A. It is 122 degrees. Then measure of angle C is already provided, 32 degrees. Now I have to first figure out the measure of angle B again, which is 180 minus sum of the other two. Right? So it is the same thing like we did here. So it's 180 minus 4, 5, 154, which is going to be 10 minus 4 is 6. And then I have 26. Let me check my math on that. Yes, that is correct. We have angle. So this kind of fits in with this triangle, right? So for this, you have to draw a different triangle, but you don't have to really draw it, but it's going to be a different triangle. So anyways, we got the measure of angle B. Now area is 1/2 of A times C times sine of B, which is going to be 1/2 times A times C. A is 16 times 10. So I'm just writing 16 times 10 times sine of 26. Guys, sine of 26 is something that we cannot see on the unit circle. So I'm going to use my calculator again. So I'm going to type in all of this in the calculator. So it is 80 times sine of 26. And what I got is 35. So the area of this other triangle is 35 feet square. So guys, these are the two values for the area because we have two triangles, so we get two areas. So I wanted to show you this example as well where the included angle is not provided or not known, although we know the other angle, but that angle cannot be directly used to find the area. For the area, we need the two sides and the included angle. But then we were able to use the sine law because we already know how the sine law works. So we were able to use the sine law to figure out that missing angle. And from that, we were actually, I mean, in this case, we also saw that we have two triangles. So we had to find the area for both the triangles, which was not too bad once we figured out the value for the angles. Okay, so guys, this is example 2 on the area of the triangle. I want to show you one more example for this section, and then we will talk about, first we'll derive the cosine law, and then we'll start actually using the cosine law to solve some examples. Till then, guys, take care. See you next time.